Hello. Okay. Hello. Good evening to all. In today's class, in last class, we have discussed two of the major interpolation techniques. One is the Lagrange's interpolation formula, and the other one is the Newton's divided difference interpolation formula. So these Lagrange's interpolation formula, Lagrange's interpolation formula or the Newton's divided difference interpolation formula, they are effective for data points which are not having uniform spacing. But today we will learn simple interpolation techniques that are effective for only uniform spacing. To point to note that the interpolation techniques like Lagrange's interpolation formula or like Newton's divided difference interpolation formula, they are effective for non uniform spacing also. That means the techniques which we have learned for non uniform techniques, they are also effective for uniform spacing. So but however, for uniform spacing problems, we can derive simpler interpolation formulas for the uniform mesh case. That means that if your data points are equispaced, we can have some simpler techniques, and here we will just use the method of finite difference. So there we have discussed method of divided difference, but here we will learn what is actually we mean by saying difference operator. So just you can just like there is differential equation. So if you have difference equation and we define the following 5 different types of operators. So like E is the shift operator. What does it means? That E of f xi is f of xi plus h. And also E of x0 equal to f of x0 plus h, which is equal to fx1. E square fxi. Now E square fxi is E of fxi. E of fxi. So E of fxi plus h equal to f of xi plus 2h equal to f of xi plus 2. In general we have, so ek of fxy, so kth order shift equation ek x fxy equal to f of xi plus kh equal to f of xi plus k, where k is any real number. For example, you can define square root of e ki power half fxi, that means f of xi plus h by 2. Okay, so now what we will discuss about what we mean by saying forward difference operator delta. So forward difference operator delta, when the operator delta is applied on fxi, we obtain delta of fxi equal to f of xi plus h minus f of xi. So when the operator delta is applied on fxi, we obtain fxi equal to fxi plus h minus fxi. So this is the notion of difference operator. So difference operator means first you take the shift operator and then you minus the original function. So you can just read these things, but we don't need actually these things to know. So first let's discuss these things. So how to make this forward difference table. So you will have some equispaced data points x0, x1, x2, x3. You will have the functional value will be given on that points. Oh, yeah, okay. The functional form will be given on that points. Now how to determine the forward difference? First of all, fx, what you need to do, just like fx1 minus fx0. So first take delta f0. Delta f0 is fx1 minus fx0. So that is the first forward difference. What will be the last second? That will be fx2 minus fx1, f2 minus f1. This is, now you note, in divided difference formula we were like taking the difference as well as we were subtracting by we were dividing by x1 minus x0, but here we are just using the difference notion. Similarly, delta f2 is f of x3, that means f3 minus f2, simply this. Next, you need to compute the second order forward difference. So how to determine second order forward difference? So you just determine delta f1 minus delta f0. So that will be delta square f0, and this is delta square f1. That means this delta f2 minus delta f1. That will be put here. Then delta cube f0 will be this minus this will be delta square f1 minus delta square f0, and that is how you need to compute move further actually. Simply there is another operator that is called backward difference operator. So the forward case you are taking like delta of fxi equal to f of xi plus h plus minus f of xi. Now backward difference operator is nabla of fxi equal to fxi minus f of xi minus h. So that is actually the backward difference operator. So first you take fxi, then subtract it f of xi minus h from this fxi function. So that will be the backward difference operator. Similarly, you can take 2 and so on like that, and you can determine this nabla square operator or nabla cube operator Huh? And um, now you just watch carefully what we actually mean by saying backward difference operator. Backward differences, see, for x, x0, x1, x2, x3, that is fx0, fx1, fx2 and fx3. So first you need to compute nabla of f. So how to determine this nabla of f? Like nabla of f1, first nabla of f1 will be f nabla of f1 will be this f1 minus f0. Then nabla of f2 will be f2 minus f1. Then nabla of f3 minus f2. Then nabla square f2. Nabla square f2 will be nabla f2 minus nabla f1, and that is how you need to just move to compute this backward differences. So I will just give one example to how to construct the forward difference table for the data. So here are your x values: -1, 0, 1 and 2. One thing you can notice that these data points, this -1 or 0 or 1 or 2, they are equispaced, right? So -1, 0, 1 and 2, they are equispaced, and -8, 3, 1, 12, these are the y values. So first you need to put in the x column -1, 0, 1, 2, then in the y column it is -8, 3, 1 and 12. So you need to compute forward difference table. So first element here will be 3, this 3 minus of -8, that means 3 plus 8, 11, then 1 minus 3 minus 2, then 12 minus 1, 11. Next, so that is how we compute the first difference table. Next, the second difference table. So that will be -2 minus 11. So -2 minus 11 will be -13. 11 minus of -2, that means 11 plus 2 will be 13. And then at last, the last column, that is nabla cube f, delta cube f, sorry, that will be 13 minus of -13. So 13 plus 13 will be 26. So you just, I am giving 1 or 2 minutes, you just read it frame by frame. Okay, so that is how we compute forward difference table. Next, simply you can also determine the backward difference table, and the backward difference table is also is same to compute. So there is no difference between forward difference table and backward difference table. Okay, hope this thing is clear. Next we will move to some of the like interpolation formulas. One is the Newton's forward interpolation formula. So okay, so like here there is some interesting problem. So that delta cube, that is shift operator, delta cube 1 minus 2x into 1 minus 3x into 1 minus 4x. So if you multiply this 1 minus 2x, 1 minus 3x and 1 minus 4x, then you will get the term x cube, and x cube will be minus 24 into x cube, right? So that will be minus 24 into x cube. That will be delta cube into 1 minus 2x. So that is delta cube into 1 minus 2x, 1 minus 3x, 1 minus 4x. So that is delta cube of minus 24 x cube plus lower order terms. So delta cube minus 24 x cube plus lower order terms. So this is minus 24 into factorial 3 equal to minus 144. Minus 144. So we will construct a forward difference table for the sequence of values f 0 0 0 epsilon 0 0 0, where epsilon is the magnitude of the error in one ordinate value and all other ordinates are exact, so that the errors propagate and increase in magnitude, and that the errors in each column are binomial coefficients. So here we will discuss the forward difference table for a sequence of values, and you just here we have written just the error term epsilon. Okay, so there is in the fourth value there is one error, and that error is epsilon. Now if you successively construct the difference table, you will observe that the epsilon 0 0 0. So eventually if you construct the difference table, then you will observe that this error is actually propagating in an increasing order. Is it clear? So next we will move to construct the table. So this is the fx. So first three terms are 0, fourth term is epsilon, the error term, and then there are three more terms 0 0 0. Now you compute delta f, first order forward difference. So here it is 0 0, but here it will be epsilon minus 0, so that is epsilon. Once again 0 minus epsilon, that will be minus epsilon. Again 0 minus 0 0, 0 minus 0 0. Next, this 0 minus 0 0, epsilon minus 0, epsilon minus epsilon minus epsilon minus 2 epsilon, 0 minus epsilon plus epsilon, 0 minus 0 0. Next, delta cube, that means the third order finite difference. So epsilon minus 0 is epsilon, minus 2 epsilon minus epsilon minus 3 epsilon, epsilon minus of minus 2 epsilon 3 epsilon, 0 minus epsilon is minus epsilon. Next, minus 3 epsilon minus epsilon, there will be minus 4 epsilon, 3 epsilon plus 3 epsilon 6 epsilon, minus epsilon minus 3 epsilon is minus 4 epsilon, 6 epsilon minus 4 epsilon, so that will be 10 epsilon, minus 4 epsilon minus 6 epsilon, once again minus 10 epsilon, minus 10 epsilon minus 10 epsilon, that is minus 20 epsilon. So how error is propagating through the entire difference table? Is it understandable that what I am trying to say, that if you have error in such of the internal data epsilon, and then the error will be magnified with a binomial coefficient type of thing, like here see 1 minus 2 1, 1 minus 3 3 minus 1, and we are having the error propagating through the entire difference table. Okay, Priyanka, are you with me? Hello.
Yes, sir.
So
Yes, sir.
is it clear?
Yes, sir.
Okay, so I will not go into details, okay, that are not like required for your this course. So I will basically stick with only what is in our syllabus only. So these things are not in our syllabus. Next we will move to Newton's forward difference interpolation formula. So what is it? This is our Newton's forward difference interpolation formula. This Newton forward difference interpolation formula means, so these methods are applicable only for, these methods are applicable only for if you have equispaced data. Okay, if you have only equispaced data, then only this method is applicable. Equispaced data means that the distance between consecutive x terms are same for all the data points, right? So this is actually our Newton's forward difference interpolation formula. Fx is f of x naught plus x minus x naught delta f naught by factorial 1 into h is the spacing, into okay, there is one typo here. Here there will be one plus term. Okay, Priyanka, that will be delta f naught by 1 factorial h plus. Okay, so fx naught plus x into x minus x naught delta f naught by factorial 1 into h plus x minus x naught into x minus x1 delta square f naught factorial 2 h square plus and so on 3 times. Then there are n data points, so you can construct x minus x0 into x minus x1 and so on x minus x1 minus 1 delta n f naught by factorial 1. Once again there is mistakes, that will be n minus 1 factorial, that will be n minus 1 factorial into hn. This is our actual Newton's forward difference interpolation formula. So fx equal to fx naught plus x minus x naught into delta f naught by factorial 1 into h plus x minus x naught into x minus x1 into delta square f naught by factorial 2 h square plus x minus x naught x minus x1 and so on x minus xn delta to the power n plus 1 f naught by n plus 1 factorial h ki power n plus 1. So this is our forward difference formula if you have n plus 1 terms. So for n terms, that will consist only up to x minus x naught into x minus x1 and so on into x minus x n minus 1 delta ki power n f naught by factorial n h ki power n. So it has permanence property, that if you add simply a data, you need to compute another this type of function and just add it with the main formula. Is it clear? It has the permanence property. Priyanka, is it clear?
Yes, sir. Yes, sir.
Okay. Next, I am giving one example. Please solve this problem. For minus 2, minus 1, 0, 1, 2, 3, the values are 15, 5, 1, 3, 1, 1, 2, 5. You need to first compute the forward difference table. Then you need to use the above formula. Okay. So what is h here? H is 1. Your h is 1, right? So you just compute the forward difference table and then you utilize Newton's forward difference interpolation formula. Priyanka, try to solve this.
Yes, sir. So 0.25.
So your computed value is 0.25.
Yes, sir.
Okay, so first you just cross check your difference table. So for -2, -1, 0, 1, 2, 3, the fx values are 15, 5, 1, 3, 1, 1, 2, 5. So -10. So next 5 minus 15 is -10, 1 minus 5 -4, 3 minus 1 2, 11 minus 3 8, 25 minus 11 14, -4 plus 10 6, 2 plus 4 6, 8 minus 2 6, 14 minus 8 is 6. So here all the terms are constant terms, so that will be 0 0 0 0 0. Next h is your 1. So Newton's forward difference interpolation formula will be this term plus x minus -2 into delta f naught, that is -10 divided by h, plus x minus x naught, that means x plus 2 into x plus 1 into this term 6 divided by factorial 2 into h square is simply 1. So that terms, so that is how you will compute it to be 15 plus x plus 2 into -10 plus x plus 2 into x plus 1 into 6 by 2. So your interpolating polynomial is thrice x square minus x plus 1. So the answer is .75, 1.25. Is it okay, Priyanka? ऐसा आया है 1.25.
Yes, sir. 1.25 or 0.25. Did a calculation mistake.
Okay. Be careful with this calculation mistakes. Okay. In the NPTEL exam, do they have negative marking?
No, sir.
Oh, then it is fine. But still, in the competitive exams, there will be negative marking. So be very careful while doing calculations. Okay. So similarly,
Yes,
this is the Newton's backward interpolation formula. So just instead of taking, so the table will be identical, right? If whatever you take delta or nabla, that doesn't mean that your table will change. So here we will take backward difference interpolation formula. Instead of taking this type of sequence, we will take from this, like that will be 25 plus x minus 3 into 14 plus x minus 3 into x minus 2 into 6 by 2. Is it clear, Bianca? Backward difference table we will interpolate from here. Okay. See, whenever you want to compute where you need, so forward and backward difference interpolation formula, they are two are identical. Now when to consider forward and when to consider backward? When the point at which you want to interpolate is close to the first few values, okay, you use forward difference table. And if your this 1 2 3 they are actually errors, this 1 2 3, if this value is close to 1 2 3, then use backward difference formula. If I give you interpolator minus 0.5, you will use forward difference formula. If I give you 2.5, you will use backward interpolation formula. So for the same problem, the table is same, you use the construct the backward difference interpolating polynomial. Please construct the backward difference interpolation polynomial. That will be 25 plus x minus 3 into 14 plus x minus 3 into x minus 2 divided by factorial 2 into 6. Then put 0.5 and tell me the answer what is coming. This is the formula. Sorry. इसका बैकवर्ड डिफरेंस इंटरपोलेशन फॉर्मूला निकालिए, सेम टेबल दिया गया है, अब बस उसका फंक्शन कंप्यूट कीजिए.
Same answer, sir. 1.25.
Same answer. Okay,
Yes, sir.
very good. Now we are giving one more problem. Mm, Next, discussing this Newton forward and backward, we will move to the trapezoidal rule and Simpson's one-third rule. Okay, for numerical integration. अब इसको डिटरमिन कीजिए. For the following data, calculate the differences and obtain Newton's forward and backward difference interpolation formula. Are these polynomials are different? Interpolate at x equal to 0.25 and x equal to 0.35. These are the table: 0.1, 0.2, 0.3, 0.4, 0.5, 1.40, 1.56, 1.76, 2.00, 2.28. You try this out. Okay.
Yes, sir. Oh, so both forward and backward polynomial are getting the same one.
Okay, so both the forwards, and so what is the answer? If you put 0.025 and 0.35, 0.25 and 0.35.
For 0.25, I got 1.655,
Okay,
and for 0.35, I got 1.875.
okay, okay. So you are correct, right? Very good, very good,
Yes.
very good. So see, first we need to compute the difference table. So the difference table is like same, right? So this is 0.1. Okay, so first you compute the differences. So 0.156 minus 1.40 is 0.16. This minus this will be 0.20. This minus this 0.24. This minus this 0.28. This is like this minus this 0.04. This minus this 0.04. 0.04. 0.000000. Okay. So now the forward difference table. Forward difference table will be 1.40 plus x minus 0.1 into 0.16 divided by h is 0.1. This increment is 0.1. Next, plus x minus 0.1 into x minus 0.2 into 0.04 divided by 2 into 0.1 whole square. This. So your forward interpolating table is forward interpolating polynomial is 2x square plus x plus 1.28, right? Similarly, you construct backward difference table. So that will be 2.28 plus 0.5 x minus 0.5 into 0.28 divided by 0.1 plus x minus 0.5 into x minus 0.4 into 0.04 divided by factorial 2 into 0.1 third whole square. So that will be this. So similarly this. So Priyanka, this forward difference table or backward difference table, they are like same and the interpolating polynomial are same. So what can we conclude from here? The interpolating polynomial is unique, right?
Sir, is it only for this case or
No, for every case. Whenever you also cross check by computing divided difference interpolation formula, you will get the same interpolating polynomial. Okay, if you construct Lagrange's interpolation formula, you will get the same interpolating polynomial. So interpolating polynomial exists and is unique. Now this here you put 0.25, 0.34. Yes.
Just before you said that if we like if the number is near to the first number, then we use forward interpolation. If it is near to the last number, we use backward interpolation. So that's why I thought it might be different.
Okay. Yes. That is a good question, right? Okay. Okay, I actually told these things because of the error propagation. So if you use backward interpolation formula, then to minimize the effect of error. That is what I was trying to connect those things actually. Okay, just give me some time. Uniqueness of interpolating polynomial. What they are telling. Okay, so here like existence and uniqueness theorem is given. It is not included. Okay, I told actually because of the error term, that error propagation term actually, that if you are given to determine okay, okay Priyanka, I will tell you in the next class. Okay,
Yes, sir.
there should be some valid reason. I currently don't remember it right now. Okay. Mm. So also you can determine this type of complex problem, right? So I will not waste much time on Newton divided difference. I will upload the book and you can actually solve the problems and all, that how to determine it and all. Okay, next प्रियंका, आपने मुझे न्यूमेरिकल एनालिसिस का क्वेश्चंस डाल दिया था ना, अब आप एक काम करना, नेक्स्ट 2 असाइनमेंट मुझे मेल कर देना.
हाँ, sir.
हाँ, उसमें क्या है, लैप्लास और फूरियर, राइट?
4 years, sir.
ओके, आप मुझे भेज देना, ठीक है?
हाँ, sir.
नाउ आई डोंट थिंक न्यूमेरिकल डिफरेंशिएशन तो नहीं है, बट न्यूमेरिकल इंटीग्रेशन आई थिंक आपके सिलेबस में है. ओके,
Yes, sir. 2 methods.
okay, one is the trapezoidal, the other one is the Simpsons.
Simpsons.
Yes. So Sir has I think discussed Newton-Cotes formulas. I will not discuss Newton-Cotes formulas and all. Just so I will just very briefly discuss that what we actually mean by saying trapezoidal rule. So see, this PQ is actually the curve. Okay, then you want to determine the sectorial area intersected by this curve and the two vertical lines x equals to A and x equals to B, and in between this area you want to measure. Now what is here your purpose? Your purpose here is to approximate the area. क्या जो इंटीग्रेशन दिया जाता है वो क्या हम हर बार सॉल्व कर सकते हैं? नहीं, हर बार सॉल्व नहीं होता है ना. So that's why we need numerical integration. So trapezoidal rule means instead of computing the entire area of the curve, you join the line segment P to Q. So what this PQBA is a trapezium. So instead of computing the actual area, you compute the area of the trapezium, right? Instead of computing the sectorial area bounded by the curve, you compute the sectorial area bounded by the trapezium. So that is actually the main funda of trapezoidal rule. So here they have briefly given the method, but we need to remember just the formula. So what is the trapezoidal rule? The trapezoidal rule is A to B fx dx h by 2. H by 2 means b minus a by 2 into fb plus fa. That means if your curve is given, you compute fb fa, you compute b minus a by 2 and then just multiply with b minus a by 2 into fb minus fa. Fb plus fa. fb plus fa. Now the error term. So trapezoidal rule integrates exactly polynomial of degree less than or equal to 1 minus 1 less than or equal to 1. That means the error term for this function 1 and x, if you compute the actual integration or you compute by using trapezoidal rule, the error will be same. The error will be 0. Got my point, Priyanka?
Yes, sir.
So for fx equal to 1, the actual integration is a to b dx. So b minus a by 2. And what will be the trapezoidal rule computed by trapezoidal rule? B minus a by 2 into f of a is 1 plus f of b is 1. So 1 plus 1 will be 2. B minus a by 2 into 2. So that will be b minus a minus b minus a, which is equal to 0. Right, Priyanka?
Yes, sir.
Now r1 fx, for fx equal to x, right? For fx equal to x, r1 fx error will be a to b x dx minus b minus a by 2 into b plus a, because f of x is x, so f of a will be b, f of a will be a plus f of b will be b, and x dx is b square minus a square by 2, this integration, and the error is 0. Now if you compute the trapezoidal rule for order a quadratic polynomial fx equal to x square, so then there will be error, right, Priyanka? So integration a to b x square dx, the actual answer is b cube minus a cube by 3. Right? There is some error here. That will be not b minus a whole cube, that will be b cube minus a cube by 3, and then here it will be b minus a by 2 plus into fa plus fb. Fa is a square plus fb is b square. You compute it, you will get this answer. So the error term in trapezoidal rule will be minus h cube by 12 f double prime xi. So minus h cube by 12 f double prime xi, where xi is some intermediate polynomial. So if you want to determine the, so what is h? H is b minus a. So if you determine the error bound, so you need to, if you have the function, you determine up to double derivative, you take the maximum. That is how you can actually compute the error bound of trapezoidal rule. Now what is composite trapezoidal rule? Composite trapezoidal rule means that you break up to a to b into a successive sub intervals. A equal to x0, x1 equal to x0 plus h and so on, कैपिटल n नंबर ऑफ सब इंटरवल्स. समझ में आ रहा है ना? तो यहाँ पे क्या कर रहे हैं हम, यहाँ इस इंटरवल को p to q को हम छोटे छोटे सब इंटरवल्स में ब्रेक कर रहे हैं, and in each and every sub intervals we are employing trapezoidal rule. Got my point, Priyanka? So this is a to b fx dx. We are using composite rule, so h by 2 will be there, and you need to, so first for x0 x1 sub interval you will get fx0 plus fx1, for x1 x2 sub interval fx1 fx2 and so on. For the last sub interval you will get fxn minus 1 plus fxn, right? Now the composite trapezoidal rule is also of order 1. So this is the formula for composite trapezoidal rule: h by 2 fx0 plus 2 into fx1 plus fx2 plus and so on fxn minus 1 plus fxn. And the error for composite formula: b minus a into h square by 12 into m2. Okay. B minus a h square by 12 into m2. m2 is maximum of these errors. So you can take common less than or equal to of n times, and then nh you can write, instead of nh you can write b minus a. Is it clear? For each of these things you just substitute less than or equal to with the maximum of this. That is how you can determine. So what does geometrically it mean? Geometrically, the right hand side of the composite trapezium rule is the sum of the areas of n trapezoids with width h and ordinates fx minus this. This sum is an approximation. Okay. So geometrically it means that the right hand side of the composite trapezoidal rule is the sum areas of n trapezoids with width h and ordinates this. This sum is an approximation to the area under the curve this y equal to fx above x axis and the ordinates x equal to a and x equal to b. These are not needed for us. So we will simply use trapezoidal rule, solve it, find the approximate value I equal to 0 to 1 dx by 1 plus x using the trapezoidal rule of 2, 4 and 8 equal subintervals. So you just solve it for 4 subintervals. No, 2 subintervals is sufficient. 2 subintervals means just break it into 0 to half and half to 1. Then just solve. So what will be the composite trapezoidal formula? That will be h by 2 into here, if you break in 2 subintervals, the h will be 0.5, right?
0.5.
So 0.5 by 2 into f of 0 plus 2 into f of half plus f of 1, and f of 0 is 1, f of half is you just determine 2 by 3, that will be I think, then plus f of 1 is once again half, you just put it, you will determine the for 2 errors. Priyanka, determine karo. And here also you can actually determine the actual integration.
So for 2 subintervals and it is 0.708, sir.
Yes, please थोड़ा जोर से बोलो प्लीज.
Sir,
हाँ,
for 2 subintervals I got 0.708 answer,
okay.
and the exact value I got 0.69.
या एग्जैक्ट वैल्यू, आपको तो एग्जैक्ट वैल्यू तो जस्ट ln1 plus 6 लेना है, ln2, right?
हाँ.
ln2 is the exact value. So for like for n equal to 2, the x is point, so fx is 1.0. For 0.5 the value is 2 by 3. For 1 it is 0.5. Okay, so now you use the trapezoidal rule, 0.25 plus 1, this 0.708334 is this.
Yes, sir.
Okay, so that is how you determine for 2 into 2. So for 4 or 8 you can just like just additionally you need to put these values inside, right? So
Yes, sir.
so for 2 it is sufficient. I think they will not ask for more than this. Okay, so what is the error? इंटीग्रल का ओरिजिनल वैल्यू तो ln2 है 0.693147. Error is point. So what you have computed this 0.708334. You subtract 0.693147. You will just get this 0.015. Now you can observe that as you increase the number of subintervals, the error actually decreases, right? As you increase the subintervals, the error decreases. So next problem is you need to evaluate 1 to 2 dx by 5 plus 3x with 4 and 8 subintervals. I just solve it for 4 subintervals. That means you need to break it like 1 to 1.25, 1.25 to 1.5, 1.5 to 1.75 and 1.75 to 2, and the global error will be b minus a into h square minus b minus a into h square by 12 into f double prime xi, right? इसको ट्राई करो with 4 subintervals. Very easy problem, not that much tough. Yep. Okay. Okay. So you for n equal to 4, your h will be 1 by 4. So the nodes will be 1, 1.25, 1.5, 1.75 and 2. Now at these points, you compute the functional value, that is 1 by 5 plus 3x. So you compute by 1 by 5 plus 3x, you put these values here, so 0.125, this, and next for n equal to 4 you get this, the values will be 5 by 5 plus 3x, right? 5 plus 3x, 1 by 5 plus 3x, you compute the values, then this will be h by 2, f1 plus 2 into it for the in between nodes, then plus f 2.0, you compute it, you get 0.10627. Also you can compute for n equal to 8, you can get that I1 is like you get 10618. So the exact value of the integral is 0.10615. Right? Now what will be the error? Just subtract this from this. So your error is 0.000012. So see, here we are using composite Newton-Raphson method, composite trapezoidal method, and error is so less, right? So, and now error bound will be b minus a into h square divided by 12 into m2. M2 is this, max of this. Now your fx is 1 by f plus 5 plus 3x, f prime x 3 by, so similarly f double prime x will be 18 by 5 plus 3x whole cube, right? This means this is actually a decreasing function. So maximum this is actually positive. So this this is a decreasing function, right? This is positive, that means f double prime x is a decreasing function. So on 1 to 2, what will be its maximum? Its maximum will be on 1, x equal to 1. So max is 18 by 5 plus 3x whole cube, that will be 18 by 512. ये क्यों हुआ पता चल गया ना प्रियंका? क्योंकि ये डिक्रीजिंग फंक्शन है. 18 by 5 plus 3x whole cube. Got my point?
Yes sir, yes sir.
So it is a decreasing function because if you take one more derivative it will be minus. So minus means that is a decreasing function. So decreasing function implies that this is actually maximum will be on 3, x equal to 1, and the m2 is 18 by 512, that will be 0.03516. error will be less than or equal to b minus a into h square. b minus a तो आपका 2 minus 1 है ना? b minus a is 2 minus 1, so that is 2 minus 1, and b minus a is 2 minus 1. So b minus a is 2 minus 1. So the error bound will be 2 minus 1 into h square, h is 0.25 whole square, divided by 12 into 0.03516. So that will be 0.00018. And what is your actual error? 0.00012. So देख रहे हो आपका actual जो absolute error है, that is less than the maximum error bound we are determined theoretically. Okay. Now you used trapezoidal rule. Evaluate the integral I equal to 0 to 1 dx by x square plus 6x plus 10 with 2 and 4 subintervals. So first you compute about 2 subintervals. Just use for 2 subintervals. That means your function will be, the nodes will be x0 will be 0, x1 will be 0.5 and x2 will be 1. You just compute it.
So 0.077 for 2 and 0.0769 for 4 separate numbers.
तो आपने 4 के लिए भी डिटरमिन कर लिया, वेरी गुड. दिस थिंग्स 0.07744, 0.07694.
Yes, sir.
Okay, very good. So for I will just discuss for n equal to 2. Okay.
Yes, sir.
Okay, so x is 0.0, 0.5, 1.0, 0.1, 0.07547, 0.05882. So these are the values. So for n equal to 2, that will be h by 2. Your h is 0.5 by 2, so 0.25. So this is 0.1 plus 2 into this value plus point this, so that will be 0.07744. So what is the error? The error is, so this is like dx tan inverse x plus 3, 0 to 1 tan inverse 4 minus tan inverse 3. Just we have written it in terms of this plus whole square, so that is 0.07677. So the error is 0.00067. So similarly, तो what does it mean that आप अगर सब इंटरवल को 2 times करोगे तो error will decrease 4 times. Is it clear? Okay.
Yes,
So next we will move to Simpson's 1/3 rule. So again we will not discuss all the things, and just we will discuss like so Simpson's 1/3 rule. Simpson's 1/3 rule says, Simpson's 1/3 rule will give you answer correct up to polynomials of degree up to 3, order 3. Okay, cubic polynomial की तब के लिए वो it gives, I think the most utilized this Simpson's 1/3 rule. So what does it call? Simpson's 1/3 rule. So break this a to b into this a to b. There we have b minus a by 2, here b minus a by 6. Here you take fa plus 4 into f of a plus b by 2 plus f of b. तो मिडिल पॉइंट में वेटेज आएगा 4 and then that will be f of b. Composite भी इसका याद करना बहुत easy है. So when I will discuss the composite, I will briefly discuss. So also error term in Simpson divided difference formula. So in Newton's error term in Simpson's rule is minus h की power 5 by 9 factorial f4 xi, and in trapezoidal which was minus h cube by 12 f double prime xi, and here it is minus h5 by 90 f double prime xi. So composite integral के लिए क्या होगा? That will be minus b minus a into h की power 4 divided by 180 f4 xi. बस simply खत्म. So this method is of order 3. Now composite interval, same, just like we note that Simpson rule derived earlier uses 3 nodal points. Hence we divided the given intervals into even number of sub intervals of equal length h. That is, we obtain odd number of nodal points. We take the even number of intervals 2n. The step length is given by this. The nodal points are given by x0, x1, x2, and they are incrementized like this. Now the composite integration formula will be h by 3 fx0. Okay, h by 3 fx0 plus 4 fx1 plus fx3 plus f of 2x this plus 2 into fx2 plus f of 2n minus 2 plus f of x2n, because there will be see, so for this 4x1 there will be against plus 4x3. देखो आप कैसे ब्रेक कर रहे हो, x0 x1 x2, then there will be x1 x2 x3, right? So you break it like x0 x1 x2. Now you will break it like x2 x3 x4. So when you use composite rule, it will be fx0 plus 4fx1 plus fx2 plus fx2 plus 4fx3 plus fx4, right? So for fx1 and fx3 the coefficient will be 4, and for fx2 the coefficient will be 2. So this is how we formulate the composite integrals. And the error in composite integral is also very, like I have discussed, just I told that b minus a into h ki power 4 by 180, that will be f, this m4 is maximum of f4 this, where x belongs to the desired integration formula. Try this using Simpson 1/3 rule. Break it into two subintervals. First use two subintervals, you break it. Okay, dx by 1 plus x. Yes?
Yes sir, yes sir.
Okay.
Point 694.
0.654. The error?
0.6.
Yes, the error. See the error. 0.001297. If you increase the interval, the error actually decreases like 6 times. देख रहे हो, errors are decreasing in 6, like not in 6, like 12. There we have like, if you increase double the subintervals, the error was decreasing in the pattern of 4. Here the error is following like pattern of 12. Here it is 1297, like 12, approximately 12 times lesser when you increase, when you double. Again approximately 12 times less when you take 107, the subinterval. Okay, so I will just discuss for n equal to 2. This is 0, 0.5 and 1.0. So this is 0, 0.5 and 1.0, and the values are like we have discussed earlier, 1.0, 0.6667, 0.5. So newtons, so just Simpson's rule, that is h by b minus a by 6, sorry So that will be h by 6. H is 0.5 by 6. So 1.0 plus 4 into this plus 2 into, correct बोल रहा हूँ, 1.0. So this is for like 2. So h is like b minus a, that is 1 by 6. So that is like first 1 plus 4 into 0.6667 plus 1, f of 1.0 is 0.5. So this is the answer. Similarly, if you just induce like one more sub interval, break it in between also. So for 0.25 it is 0.8, 0.75 it is this, and then you need to like f0 plus 4 of f.25 plus 4 of f.75 plus 2 into 0.05 plus f of 1. You will determine this as, and your this is like h by 3. So h by 3 is like h is 1 here, h is actually here, here the h is point, here h is 0.25. So 0.25, that means 1 by 12. So that is how you can actually determine the composite Simpson's one-third rule. Okay. Okay, just use similarly use Simpson's one-third rule. Evaluate the integral I equal to 0 to 1 dx by x square plus 6x plus 10 with two subintervals. Two subintervals means 0, 0.5 and 1, and four sub so 0, 0.5 and 1. So your h will be 1, b minus a by 6, so 1 by 6 plus your just into f0 plus 4 into f of half plus f of 1. So just compute it. For this you will get x, this fx is 0.1, 0.07547, 0.05882, and you just h by 3, 0.5 by 3. So f00 point this, so you just put here the value 0.07547, here 0.05882. Your answer will be 0.07678. These are actually very rigorous ones, and you see the error will be here very less, 0.401 like that. See point this. So up to Simpson's one-third rule is up to your syllabus, right?
Yes, sir.
ओके प्रियंका, आप एक बार वो शेयर करो अपना जो ट्यूटोरियल था। मेरे पास क्या है मैं देखता हूँ। नहीं, मेरे पास नहीं है। ओके, आपके पास अगर क्या है वो दो ट्यूटोरियल्स भेजे थे आपने? यस। तो आप एक काम कीजिए, अगर शेयर कर सकते हो तो शेयर कर दीजिए, मतलब स्क्रीन शेयर कर दीजिए। आई विल डिस्कस दैट। आई एम स्टॉपिंग माय प्रेजेंटेशन। ओके। Yes, thank you.
Is it visible, sir?
Yes, yes.
PDF is visible, sir?
No. Yes, it is visible now. Visible, visible.
Visible, sir?
Yes.
Okay, sir.
Yes. So see, question number 1. You see question number 1. Question number 1 is like fx is a function defined on the interval this, such that f of this, the quadratic polynomial px agrees for x equal to -1, 0 and 1. You need to determine the interpolation error. So what will be the interpolation error? So आपको 3 points के लिए दिया गया है. So your error will be x into x minus x plus 1 into x minus 0 into x minus 1, that she has that instructor has already written, into your error will constitute f triple prime I, because you have 3 values. So that's why there is this a is correct. So this is actually the error term. Okay, next. This given statement is true. Why? Because this is just Weierstrass approximation theorem. Any continuous function on a closed interval can be well approximated by polynomial function, and this given statement is true because this is a direct statement of Weierstrass approximation theorem. So A is correct, it is true. Next. देखो, Newton's forward backward interpolation methods are used for equally spaced intervals. True. Newton's forward and backward interpolation methods are used for any intervals. No. False. Delta square fi is not, this is not correct. Delta square fi is f of I plus 2 minus 2f I plus 1 plus fi. First you compute delta fi. Delta fi is f I plus 1 minus fi. So next once again compute delta fi plus 1, fi plus 2 minus fi plus 1. यहाँ पे गड़बड़ी कर दिया लग रहा है इन्होंने, टाइपिंग मिस्टेक कर दिया, राइट? There will be minus sign here, there is a typo here, please correct. This will be minus of f of I plus 1 minus fi, so that will be fi plus 2 minus 2 fi plus 1 plus fi. ये जगह पे एरर है, प्लस की जगह पे, ठीक है, थर्ड लाइन पे. So A and D are correct. Next, move. Okay. तो हमने तो ऑलरेडी इसको डिस्कस कर दिया है. So delta fx1 will be 177 minus 158, 19, correct. Efx1 is shift operator, so that will be 177, correct. Nabla fx1 is fx1 is 158, so nabla fx1 will be 158 minus 143, that will be 15, so this is also correct. E of fx1 will be 177, but they have given 158, so D is false, so ABC is correct. ABC are correct. Next. Okay, similarly just you need to compute Newton's forward interpolation formula, and so you just need to compute the difference table we have already discussed today, and you just use the forward difference table. So that will be 0.423 plus x minus 0.4 into 0.261 divided by 0.2 plus 0.018 0.085 plus into x minus 0.4 x minus 0.0 x minus 0.8 by factorial 3 into 0.2 whole square, yes, 0.2 whole square, sorry 0.h whole square, and that is how you just use the forward difference interpolation formula and you just get the answer, and the error you will find out to be 0.002. Next, okay, Newton's backward interpolation polynomial for the following data points. Again, similarly, you just compute the table, you just take the backward interpolation formula like this: 6 2 6 minus 3 1 10 2 4, and that will be your answer actually. इसमें डिस्कस करने के कुछ है ही नहीं, प्रियंका, है ना, इजी है, दिस क्वेश्चन इज जस्ट यू हैव टू यूज द फॉर्मूला. ओके, नेक्स्ट, नेक्स्ट वन सेकेंड, न्यूटन्स डिवाइडेड डिफरेंस फॉर्मूला तो हमने लास्ट क्लास में डिस्कस किया था. न्यूटन डिवाइडेड डिफरेंस फॉर्मूला में एक चीज याद रखना प्रियंका कि न्यूटन्स डिवाइडेड डिफरेंस फॉर्मूला में फैक्टोरियल 2 या फैक्टोरियल 3 से सब्ट्रैक्ट नहीं होते हैं, ठीक है, ये कभी कभी बच्चे गलती कर देते हैं. ओनली इन फॉरवर्ड और बैकवर्ड वी यूज द लाइक 1 by factorial 2 or 1 by factorial 3 like this. Okay, so these things already we have discussed in our last class. Just you use this notion, the divided difference, you write them consequently: 1 plus x into 1 plus x into x minus 1 into 1, and that will be your polynomial. Next, Lagrange interpolation formula. Lagrange interpolating polynomial we have already discussed. -1 0 2, your Lagrange interpolation for minus, this will be x into x minus 2, but -1 by -1 minus 0 into -1 minus 2, these things you compute L0x, then you L1x for this, that will be x plus 1 into x minus 2 divided by -1 minus 0 into 2 minus 0, that will be your polynomial here, Lagrange polynomial here. Once again, for 2 you determine the Lagrange's coefficient, you multiply with 10 7 7 with those polynomials, just multiply, you will get the Lagrange's interpolating formula. Here we can't use forward or backward difference interpolation because the data are not equispaced. Okay, next, okay, now the trapezoidal rule. So here this question is good question. So how many subintervals you require so that the trapezoidal error, the error is less than 10 to the power minus 4. So the composite error for composite trapezoidal rule, the error will be b minus a. b minus a is b minus a into h square by 12 into m2, and m2 is your max of double prime x, and once again you can compute it to be a decreasing function. This max will be obtained on 0, so that will be like 1 by 32, and this error b minus h square by 12, this will be less than or equal to 10 to the power minus 4, and this h is actually b minus a by n. N is the number of subintervals. You from here you will get an inequality 1 by 48 n square, that will be less than or equal to 10 to the power minus 4. You divide n, so if you take n equal to 15, then your error will be less than 10 to the power minus 4. Next, using Simpson's 1/3 rule, you determine the value. So for 1.47, the where is fx? fx का टेबल दिया गया है. So your this so Simpson 1/3 rule will be h by 6. Your h is 1.49. Sorry, b minus a by 6. b minus a is 1.49 minus 1.47 is 0.02 divided by 6, so that is a 0.01 by 3, and then f of 1.47 plus 4 of f of 1.48 plus f of 1.49, you add them up, you will get to be 0.01 by 3, 3.86 plus 15.6 plus 3.96, you calculate it, you will get it the answer to be 0.078. So that is, so from what we have discussed in this problem also you can easily actually solve these assignments also. So that I am choosing the following a standard book, so that you can get a glimpse of variety of problems, and just need not to read the entire book, just follow whatever is in your syllabus. Okay, so that is all.